Good afternoon, everyone. My name is Simran Maurya with the Energy Management Association, and I'd like to welcome you to today's webinar and thank Facility Grid for sponsoring today's session. A few items before we get started. Presenters will be holding questions until the end of the presentation, but we encourage you to submit them at any given time using the Q&A button. If you happen to be experiencing technical problems during the webinar, please use the chat function to inform the panelists, and our technical expert, William, will assist you. The presentation is being recorded and will be available for viewing in 1 week. In terms of continuing education credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you are a certified CXA or EMP, your CEUs for attending this webinar will be automatically uploaded to your respective portal. Today's webinar is Building Confidence, a roadmap to achieving operational readiness through data center commissioning. Let me go ahead and quickly introduce our speakers for today. James is a principal of MACx Consulting, an independent third-party commissioning advocate. He founded Kentucky's first independent commissioning firm, leading 423 projects before transitioning in 2020. After FCG successfully commissioned over 800 projects by 2023, James joined MACx to support ASHRAE SSPC 300 and the ACG Building System Commissioning Guideline. He also serves as treasurer of SERBCA, a director of EMA, and a member of ACG Accreditation Council Exam Writing Committee. The second speaker we have today is Alex. Alex is a former mechanical engineer, a CX manager with over 25 years of experience in master planning, project management, mechanical design, construction administration, startup, and commissioning across multiple industries. He is an active member of ASHRAE SSPC 300 and advocates for clients in developing product strategy. Thank you again, everyone, for joining us. And with that, I'll hand it off to our speakers to kick us off.
Thank you, Sam. Hello, everyone, and welcome to the presentation, and thank you for attending. Again, my name is Alex Kozinets. I am a Chief Customer Officer at Facility Grid. I'm also co-founder of Facility Grid, and my job as Facility Grid is to make sure that our clients have sufficient tools and knowledge to manage their projects in our platform and be successful in doing that. Jim?
Yeah, and now you have data center experience too in your previous history. You worked with data center commissioning and so forth too.
Absolutely.
I really came to data center commissioning through my work with SERPCA, Southeast Region Building Commissioning Association. And we started 7x24 Carolinas meetings 15 years ago, where we were supporting the mission critical facility by doing an annual technical summit. And it was then that I gained the insight and then over the years knowledge of how really unique and different it was. And Alex, you and I just recently saw each other at the ASHRAE meetings in Orlando, where we went through 12 meetings in 4 days and almost 30 hours worth of volunteer. Any comments on what we did in Orlando? I thought it was real exciting.
Agree. I think it was a great set of meetings, meeting peers, talking about the issues of commissioning challenges, commissioning, especially those related to data centers, with everything that's happening, with all the opportunities in the world of commissioning of data centers. Yeah, we get great time.
Alex and I both serve on the Standing Standards Publication Committee for Commissioning, which is SSPC 300. And Alex is on the committee that's producing an ongoing commissioning guideline to be published in the near future. And I'm on the committee working on the data center guideline, and we support each other. And also, I see you a lot at ACG and also in the BCA annual meetings. So Alex, why don't we get into it?
All right. We are ready to start, ready to get going. Just a quick note, Bill and I will be switching our cameras off so that you can concentrate on the content instead of looking at us, but we promise you we're still here, not going anywhere. Like commissioning process, that never disappears. All right. In today's presentation, we're going to talk about data center opportunities, commissioning process and how it applies to data centers. We're also going to talk about operational readiness of data centers. And then at the end, we'll turn our cameras back on and we'll take your questions. And hopefully we'll be able to answer them. So we wanted to start this webinar by sharing with you some stats on growing opportunities of data centers. You've probably seen the stats before. You've seen these numbers before, but we still wanted to emphasize really the extent of these opportunities. So the primary driver of expansion of data centers today is obviously artificial intelligence, machine learning, high-performance computing. In addition to that, autonomous vehicles, Internet of Things, 5G networks drive the need for edge data centers, right? These are the smaller facilities that are typically located closer to users to reduce delays and improve speeds. We're also seeing expansion of data centers, not just in Europe and the Americas, but in other parts of the world, Middle East, Asia, Southeast Asia, East Asia, and Africa. And as more businesses and governments are investing in digital infrastructure in those regions. And also, data centers are now becoming more sustainable. They obviously use tremendous amounts of power and water resources, and those need to be conserved. Jim, any additional trends you want to highlight?
Yeah, I would like to look towards the energy side of the equation, and I think the growth from AI is very significant. And the fact that rather than using the traditional CPUs or central processing units in order to do AI, we utilize GPUs, which are graphical processing units. But the difference is the GPUs consume 10 times as much power as CPUs. So if you look at data centers consume power at an industrial level because of that. If we go back to the Granholm, the last report in December of 24 from the, or December of 24 from the DOE, the United States consumed 4.4% of its electricity through data centers. And the DOE predicts that by 2028, between 2 to 3 times that amount of electricity consumption will be needed to feed data centers. So it's an amazing amount of increase in energy being used. The big four industries, the chemical, metal, cement, and paper pulp industries aren't going to double in the next 5 years. So the amount of power this puts on the grid is amazing. So solutions aren't as easy as they seem. A lot of people think that, well, you can put a small reactor on a nuclear reactor on a site, an SMR, but those haven't been approved. If you wanted to go to put a natural gas to produce local energy, like in a direct energy source, you wouldn't be able to buy the generators for years. So there's a lot of problems in getting the energies and a lot of issues around water consumption, since it's also a top 10 consumer of water. I saw, Alex, on news this week that Equinix, which is a data center developer, had connected 100 plus megawatts in fuel energy cells in order to feed their international business exchange of data centers in the United States. And they were going to bring another 30 megawatts of fuel cells online. So a lot of direct energy sources are going to be used in data centers, solar panels, wind, batteries, and so forth. So in addition to the energy need, it's also a community issue, which is where the ESG comes in on data centers too, because it impacts. My sister lives in Sykesville, Maryland, and there's a data center alley in Loudon, Virginia, and they're being pursued for right-of-ways because they need to bring electric power additionally to the data center where there's 100 data centers clustered. So hyperscaling and all these issues impact the way we build, operate, and commission these facilities. Sorry, I got a little winded there, Alex.
No problem, but this is great information. And obviously, you can easily tell that not only that the data center opportunities or demand for data centers keeps growing, but so does their complexity, right?
That's right.
As we know, data centers are already some of the most challenging facilities to build and commission, right? But with these increased needs for sustainability, scalability, resilience, really the commissioning process is even more complex. So if we just look at some of the contributing factors for this is, data centers rely on standard, specialized critical infrastructure to handle power and cooling needs, right? They need repeatable, standardized processes to enable rapid deployments. They need innovative, energy-efficient solution to meet those sustainability demands that Jim was just talking about, right? And finally, they require traceable documentation to meet regulations. Now, in addition to all of this, data centers must be fully operational on day one and meet the uptime expectations. Also, they require seamless handover at project completion. So for successful day one, day two, and beyond. So with all of this in mind, welcome to the world of commissioning of data centers. But if we look at the commissioning of data centers, let's try to figure out what is so different about that. Here's just some examples. Well, first of all, data centers have very strict industry standards for uptime, right? They typically come from the Uptime Institute tiers, right? And complying with the standards or not complying with the standards can lead to severe consequences. Multiple overlapping systems, such as cooling, power, security, networking, they all must work seamlessly together. Also, to verify that compliance with uptime, commissioning has to go through testing for redundancy and various failover simulations. Also, with all of that in mind, there are very tight speed to market requirements. So you mentioned company Equinix, Jim. They have very, very tight requirements for how long it should take for a data center to be operational. And I'm sure this goes for every other data center in the world. And so these requirements really leave little room for errors and delays. But before we dive into operational readiness process, for managing quality control and commissioning of data centers, Jim, why don't you walk us through various commissioning standards, guidelines, publications, and tell us about this whole new beautiful guideline for commissioning of data centers.
Thanks, Alex. I appreciate that. And, the tools that we need in order to perform the commissioning, and what I want to do is go through those so that we can make a connection to the main point of this conversation, which is how do we connect the commissioning process with the quality control process, specifically through operational readiness. But the tools we have, ACG has a building systems commissioning guideline, which we've produced in 2 parts now, just republished. We've completed the comprehensive building systems commissioning process, part 1, and we've started significant work and publication on the applying the process to specific building systems. I also chair the 1.6P committee that Alex mentioned, that we're trying to write a guideline for commissioning data centers. I hope to have our first draft for our meetings in June, I guess in Phoenix. But in reality, the ACG Building Systems Commissioning Guideline is based on ASHRAE 202. And the reason is that in order to do really good professional work, a lot of times, development, construction, commissioning, and operation require standards and guidelines so that we can promote public safety. We can express minimum requirements. And I think there's an understanding that we should have that a standard, although the word sounds more strict, is actually the minimum requirements. And we look to the guidelines to find suggestions and best practices. And then those guidelines have annexes that I'll talk about. And in the end, one of the significant factors that distinguishes what we're producing in the data center commissioning is these levels of commissioning. There's a lot of other factors as well that are unique, but that's a big one. So let's move on and look at a couple of the documents and things that are available. So Standard 202 was originally published in 2012. It's a consensus document of the minimum requirements to do commissioning process. And I say all this because the commissioning process, as is laid out here, is applied to data centers. It's just we do additional things when we commission data centers. I recommend to everybody the strategic guide to the commissioning and the commissioning stakeholders guides as resources to get a general grounding on how the process works through all the parties involved. And there are 3 sources within ASHRAE to get definitions, terminology. One is this commissioning definitions publication that you can find on the website. Another is each standard has a section of definitions. And the third is a link that I'll show you that's an ASHRAE definitions link. So the next document is the ASHRAE Standard 230, which was just published. So go ahead, Alex, in 2022. You can move up on it. There you go, Alex. The Standard 230 is actually the commissioning process for existing buildings. And like I said, it was published at the end of 22. In addition, in the last 5 years, there's been an update to Guideline 4, which is the operations and maintenance documentation for HVAC and refrigeration systems. And then there is now a guideline for design, installation, and commissioning of VRF systems. And then these are the rest of the documents that are published and are available. And these are the tools that can help you to produce. Guideline 0, as I said, has many more suggested practices and best practices. And when you go to the annexes and the appendices, even examples. 0.2 is the commissioning process for existing buildings. 1.1 is commissioning process for HVAC and R. 1.2 is the requirements for existing HVAC and R commissioning. And then we have 1.3, which is the building O&M training for HVAC and R. And then we have 1.4, which is of details of how to prepare a systems manual. And then 1.5 is the commissioning process for smoke control systems, probably going to be republished or updated this year. And then, as I mentioned, there's 1.6P that I'm on for data centers, and then Alex is working on 0.3, which is going to be the guideline for ongoing commissioning. I mentioned the annexes, and if you go to this link up here and you click on it, you will move to the next slide, and that'll show you all the different common annexes related to the guidelines. Rather than repeating every one of these in each one of the guidelines, they're freely available on ASHRAE's website. And really, this is a tremendous amount of information that can help in building commissioning processes and documentations. And you can see it handles the various elements of the commissioning process, from submittal review, issues logs, testing and observation, and so forth. So moving from there, let's talk a little bit about data centers. There's the terminology link, which is the third source of definitions and terms from ASHRAE. The link below is really a good link to have. TC 9.9 is the data center committee, and they're concerned with the mission of critical facilities, data centers, technical spaces, and they want to upgrade the knowledge and information. And in doing so, they've created a data center encyclopedia, which you can find on this data center resource page. And there's a $24 a year subscription, but in exchange for that, you end up with all the guidelines and everything else that used to be published. And it's an amazing resource for information. And we're going to be utilizing this, as I explained to you on the next slide, about 1.6P, which is the commissioning for data centers that we're working on. Alex, thank you for your help on that. And we're really the first building specific guideline for data centers. And the reason is just because data centers tend to be such an atypical building, and they have a lot of unique attributes. So the thing is that a lot of factors that are normal in commissioning are even more emphasized in data centers. For example, training. You know, data centers are an aging workforce in an exponentially growing industry. So the emphasis on training for a lot of new personnel and a lot of transitional personnel is very important. And we talked about, energy resources and water resources. When a data center moves into your neighborhood, it's a stress on the community. It's a stress on resources and energy consumption. Super high energy needs, and then security needs and hyperscaling come into play on these data centers. Alex mentioned the timeline issue, which in data centers is unique too. You have to account for full stop commissioning. In other words, when you get to that scheduled end date, it has to be done. It has to be commissioned, and you cannot usually get back into it. So the planning, years in ahead or so is required to make sure that you can get to that end point. And this is again where the commissioning and the quality control need to come together. General contractors, construction managers, they understand how to manage these parallel paths of construction and commissioning. But what we really need is in the area where product is starting to be delivered to the site, equipment is installing, tests are being done by the vendors and the installers. These are the periods of time when the commissioning and the project management really need to come together. Commissioning and quality control need to develop a unique bond with each other. How are mutual deliverables leveraged to support the common goals that quality control and commissioning have? And that's really what Alex is going to start moving into now. Where do these two parallel paths come together? And the one thing I want to think about when Alex starts talking about it, think of OPR to the commissioning provider in the sense of it being the guide, and think of operational readiness as the key for the contractor side. So Alex, tell us about that.
Well, thank you, Jim. That was great. Tons of great information. And I hope that those who's listening is that you understand that data center commissioning guideline is the first real guideline that is specific to a particular building type, right? It's not just a process, but it's a building type. But traditional commissioning, is no longer enough when we're talking about commissioning of data centers. And that's where we get to operational readiness, right? What is operational readiness? So operational readiness is a proactive approach tying together three main areas, right? All you need to remember: equipment, data, and people, right? The goal of operational readiness is simply to ensure that all building assets, such as cooling, power, security, monitoring, pretty much every building asset, are tested and validated. The second part has to do with data. So all asset data and documentation, such as compliance record, test results, anything that's required to be handed over to the building owner, to the owner of the data center, are fully complete. And the third part is all personnel responsible for operating the facilities are fully trained and ready on day one and beyond. So, but in addition to operational readiness being a process, it is also mindset. And mindset, because it requires a buy-in, not just from commissioning provider, but it also requires a buy-in from every project participant. It starts with the owner, who outlines the owner project requirements and the entire requirements for the commissioning process and for the ongoing commissioning process. It also requires a buy-in from general contractors and its trade partners, and obviously the commissioning provider as well. It also requires a clear roadmap and collective goals at each project phase, which, when we talk about commissioning of data centers, we're talking about commissioning levels. So we're going to talk to them a little bit later. And finally, this process creates accountability as well as enables a path for success. So naturally, to succeed, operational readiness needs quality control and commissioning to be in lockstep with each other. Achieving operational readiness starts with ensuring that quality control activities are fully completed before on-site commissioning begins. And I specifically mention on-site commissioning so that there's no confusion. Commissioning starts at owner project requirements, but typically on-site commissioning activities starts at the completion of quality control activities. And it is very also important to note that commissioning is really not about troubleshooting. The main goal of commissioning is to validate the success of quality control process, which is typically carried out by the contractors, right? After all, contractors carry all the risk for delivering the successful project. Commissioning providers do not carry any risk. If contractors are not fully engaged in this process, then last minute failures during functional testing can cause major project delays. And also, poor quality control documentation will make it very difficult to verify readiness for day one. So we talked about operational readiness being a process and that it relies on three components: equipment, data, and personnel, right? And what we're going to be talking about right now is the commissioning levels. The new data center guideline 1.6 will be talking about the levels and what those levels mean. But basically, when teams follow these approach using the levels, they can ensure that at every milestone, these components, which again, equipment, data, and people, are addressed, and any surprises that can occur during project completion are eliminated. So now let's take a look at this, at the levels, and see how they can help in delivering operational readiness. So this slide, when we built it, we wanted to communicate the important milestone, and this slide represents the workflow of operational readiness process. But each major step is a milestone in the process. So it starts with pre-construction completion, right? Pre-construction completion is typically covered by level 0 and level 1. And by the way, sometimes you'll hear a reference to levels 1 through level 5. We like to talk about levels 0 through 6 because we think that it is very important that any activities that relate to operational readiness during design phase and also during the handover phase are included in the process. So during level 0, this is where all the project requirements are established, where the commissioning plan is put together by the commissioning provider. Also, any design reviews are reviewed, and also submittals are reviewed by the commissioning team along with the design team, and all the comments are documented. Once this is done, we move to the level 1 activities, which has to do with off-site testing. So off-site testing can be either at a factory of a major equipment, electrical or mechanical. They can also, and this is what's called typically factory witness testing, if a representative from the project team attend the testing and witness it, or it can be just a factory acceptance testing procedure where a factory conducts similar tests. However, the project teams do not witness it in person, but they do get all the documentation at the end of the testing. And also bench testing activities would occur during level 1 phase. This is where different systems can be tested together, maybe at a controls contractor facility, and to ensure that the proper systems are going to be put in place together. Now, at the completion of these 2 levels, this is what's called pre-construction completion, right? Again, we're talking about 3 components: equipment, data, and personnel. So at the end of this 2 levels, what we want to make sure is that we do have the right equipment being specified and procured. We want to make sure that that equipment can and will be able to perform in accordance with the design intent. We have all the documentation supporting all that information. And also, at this point, if activities like bench testing or factory witness testing occur, it's a really good idea for the owner's personnel to attend those tests, to witness them firsthand, and they will understand what to expect. And if they need to make any suggestions or ask questions, this is the perfect time to do it before that equipment or systems are installed at the facilities. Then we move into the level 2 activities. Now, these activities have to do with static testing, right? This is where the quality control plays the most important part. What we show here is two separate phases of level 2s, level 2A and level 2B. So level 2A has to do with installation of equipment. First of all, we want to make sure that the right equipment arrived at the job site. We also want to make sure that it is set in place correctly, per requirements, per specifications. And also that that installation has been verified, making sure it has the right connections, it has the right clearances, and so on and so forth. Now, you would also notice on these slides that there are tags, right? What are tags? So tags are color-coded labels that get attached to equipment at different stages of commissioning process. And what they do is they clearly display progress of each asset throughout the operational readiness process. You can think of them, of these tags as gatekeepers at each commissioning level to ensure that the quality standards are met before it is, work is allowed to move forward from one tag to another. Now, the colors can be different based on the requirements of a particular, data center owner, but the idea is exactly the same. You cannot move to to the next tag before the previous tag is completed. And the completion of the tag is not necessarily just, completion of a certain test. It also means that you have the supporting documentation that is associated with that phase of the project, and also issues that relate to that equipment also have been addressed. Now, there are different types of issues that you may have, and typically it is established early in the project which issues can trigger a block of moving from one tag to another, right? But basically, again, the tags are, think of them as gatekeepers. Now, once the level 2A activities are completed, we move to the level 2B. So these activities are all about quality control testing. This is static testing where the trade contractors will perform inspections, will perform tests. These can be pressure tests, point-to-point verification, continuity, mega tests, any type of test that they are responsible for per the spec requirements to ensure that the systems are statically complete. Now, at the completion of this phase of the project, again, think of people, data, and equipment. So we know that equipment is statically ready. We also know that you have all the supporting documentations, all those testing information has been collected and is going to be ready for handover at the end of the project. And we also know that building personnel is naturally going to be part of this. They're going to be walking the site. They're going to be witnessing the testing, and because this is the perfect time for them to learn and to understand what equipment is there and why it is there. The next phase has to do with mechanical completion. A lot of times, level 3 is mentioned just as one activity. We like to break it into level 3A and 3B. And level 3A has to do with verification of pre-energization of the assets and then the startups. Okay, so these typically are conducted by manufacturers' representatives, trade contractors, and at the end of those, at the startup, the trade contractors will perform testing and balancing activities. Now, once those activities are completed, this is where the pre-functional testing checklists are being completed by the trade contractors. Typically, they're created by the commissioning team. And the purpose of this checklist is really to verify that all previous steps have been completed, all documentation has been collected, and any witnessing that had to occur, by the operations team have happened. Now, once mechanical completion is complete, the equipment gets a green tag. And so now you have a green light to move to the next phase. So the next phase is the dynamic testing, right? So the dynamic testing is typically broken into 2 phases, level 4 and level 5. The level 4 activities are typically functional testing. This is the where equipment and systems are tested individually to make sure that they can perform per the owner requirements, design intent, and submittals. We also like to include pre-verification testing in this phase. And pre-verification testing has to do with ability for trade contractors to pre-test equipment before the formal tests that are conducted by the commissioning team. These are typically identical test scripts that become available, to the contractors. And, basically, it's like walking into exam with an open book. It gives you ability, or gives the construction team ability to pre-test equipment and, to make sure it's ready. Now, when the functional testing is completed, the equipment gets blue tag. And then we move to the last phase of the, or the last part of the dynamic testing phase, right? This is the level 5. This is where all the systems are tested together. This is the integrated system testing. This is where test scripts through various, testing activities that verify redundancy, that verify resilience of the facility. At the end of this phase, the equipment will get the white tag. Now, once the testing is completed, this is what, this designates the completion of the dynamic testing activities. Again, very important. At the end of this activity, we have equipment, data, and people ready. Again, equipment, we just verified through all these different types of testing activities. The equipment is ready, systems are ready.
Alex, there's a lot going on with this roadmap that we've got. You got the 5 phases of completion. You've got 7 levels. I like the way you break down the levels more discreetly so that you have a step path to get to the completion phase. The tags, if you could tell us a little more about the physical use of the tag as well as documentation use of the tags, as why they're beneficial. And the idea, I think, is that you want to have operational readiness at the green tag so that you can flow through level 4 and 5 and really get validated for it to get the white tag.
Correct, Jim. And at the completion of level 5, right, this is again where all the you have everything, all the documentation, everything is ready. The operations team is ready to take over. They've witnessed various activities. They know, they understand the systems and equipment of the project that is basically handover. This is the level 6 activities, and during the level 6 activities, when them personnel is being trained, so anything they haven't witnessed, or if they have any additional requirements for training, this is where that additional training occurs. Also, this is where the project turnover and the closeout documents being put together and signed off and provided to the building owner. Any end of the warranty inspections occur. This would be typically after first 12 months of the operation of the building. Also, the commissioning team together requirements for day 2 testing activities. So any ongoing testing that need to occur periodically throughout the life of the facility. And very importantly, the commissioning provider will work on an ongoing commissioning plan to ensure that the building can work sustainably moving forward.
Okay? And then this is where we would do off-season mode testing and off-season mode training as well.
Absolutely. So anything that's still that's still required to verify that a building is ready for day one. This is where it would happen right here. Now let's talk about the digital tools that can help manage this process. Obviously, there's a lot happening. There's a lot of people involved. You have very critical system, complex systems, and there are tools that available today, that can help you manage the commissioning process. But when you talk about commissioning of facilities, critical facilities like data centers and others, it is really important that the program that you may be using already or you may be looking at can provide you with ability not just to track individual quality control or individual commissioning. You really want to be able to have a dedicated operation readiness application that can track the entire quality control and commissioning process in single place, right? And that will ensure the seamless coordination. You've seen from the presentation the key in the handshake between quality control and commissioning, right? And so what you want to do is you want to be able to have that operation readiness process being managed in one place. The right application can also provide real-time visibility into testing progress to make sure that all the teams are aligned. You want to make sure that your application can talk to the construction schedule so that not only you can track your activities on the status, you can also track them on the status based on the project schedule. Because knowing whether you completed or not, independent of the schedule, can't really give you enough information. You always need to know where you are versus where you're supposed to be. Also, you want to make sure that the tools you're using can validate that the quality control is completed and documented before commissioning, on-site commissioning activities can begin. You want to make sure that every project stakeholder has clear expectation of the responsibilities. So this process of levels that documents the phases and the milestones and the requirements, you want to make sure that every stakeholder has access to that information. At any point of time, they can track what's the status of that asset. And using those tags that we talked about in the previous slide, you want to make sure that the software can help you identify the right tags. You also want to make sure that the software can help you identify issues as early as possible. So whether you're starting at level 1 or even better at level 0, you want to make sure you can document the issues as early as possible to reduce the rework, because catching the issues early on the project costs much less and takes less time to address. You also want to make sure that the delivery of the data center, operation readiness data center happens on time, right? So again, as I mentioned before, you want to make sure that your progress can be tracked against the schedule. So you'll always know where you are versus where you're supposed to be. And also, when you have every team, whether it's owner, contractor, trades, manufacturers reps, and so on and so forth, commissioning providers, as they work together through the construction life cycle, you want to make sure that there's a platform where they can clearly and easily communicate, plan, and collaborate throughout that process. And most importantly, you want to make sure that you do have those data-driven insights, that commissioning becomes a strategic and measurable process rather than a last-minute task.
Yeah,
and,
good.
And my last slide is basically to summarize our presentation. And to achieve operational readiness, achieving operational readiness drives measurable business impact. So by ensuring that systems, data, and personnel are fully prepared before data center goes live, your organization can reduce financial risk and downtime. It can accelerate commissioning and handover. It can enhance compliance and stakeholder confidence. It can improve project predictability and efficiency. And as a final thought, by embedding operational readiness into the data center lifecycle, organizations can protect their investment, ensure reliability, and set the foundation for long-term success. All right, we're back on.
Thank you so much, Jim and Alex. I am going to go ahead and start the questions. I did see we have quite a lot of questions that have come in. So let me start with the first one. Todd would like to know, does ASHRAE have a data center standard?
The ASHRAE guideline 1.6P is being written with the intent of moving it to a standard rapidly. So the 1.6P effort is the standard effort. They're the same thing. So once we get 1.6 published as a guideline, we'll probably start work right away to try to move it into standard language and get it published as a standard.
Got it. Thank you, Jim.
And that's typical. I mean, guideline 0 took a while before it became 202 as a standard. So ASHRAE's usual process is to go guideline, then standard.
Interesting. The next question would be from Chuck. He's asking, during pre-verification, is the CXA on site, or is this something that the contractors would do on their own using FPT test forms?
So typically, during pre-verification testing, those tests are conducted without commissioning provider being on site. There's nothing wrong with commissioning provider being there and just kind of, poking and seeing like what's happening. But the goal there is that the trades perform testing ahead of the formal test. The goal of that pre-testing is really figure out whether there are any discrepancies between the understanding of how the system supposed to work per the owner requirements, per the standards, and what contractors have built, have installed, have programmed. Now the difference can come because of various various things. So for example, it may happen that there was an RFI that revised based on which sequence operation has been revised. So to address this, sequence operation may have changed, but commissioning provider may, maybe was not notified of that. So the functional test script remained unchanged. So the goal of that test conducted by the contractors is to catch things like this and then communicate any deficiencies that they find with the commissioning provider, so that then when the formal test occurs, those items can be eliminated.
And then this is a really good spot where the quality control handshake is occurring with commissioning. The quality control plan and the commissioning plan need to both account for operational readiness. So the commissioning provider must provide the written test scripts to the contractor if he's going to do them ahead of time. The contractor has to be motivated by their own quality control plan in order to execute those and have the resources to do them. But the OPR needs to mention operational readiness as a contingent. And then this is a really good spot to include the pre-verification testing using your test script. So you walk in on the day that you're doing formal tests and observations knowing you're going to pass. That's the important key that Alex is trying to get across.
Interesting. Thank you so much, both of you. Moving on to the next question. Jim says, at which level or levels are HVAC DDC tested?
It's a broad question. HVC, so control systems are can be tested at multiple levels. So as I mentioned before, it can start even during level 1 when you have bench testing. So you may have a situation where you can test how control systems, HVC control system can operate and communicate, for example, with fire alarm system. So then you take different activities. The contractors will perform multiple activities throughout the quality control process. And this would be to, for example, verify point-to-point checks. And so, all of that is pre-tested, making sure that, those, all the controls, all the sensors, everything is set. And then the final testing activities, right, after the pre-verification, but the final testing activities would be happening during the level 4, during the functional testing of equipment and individual systems. And most importantly, they play a huge role during the level 5 testing, where everything is tested together, where you go through multiple scenarios of failures of different systems, and to make sure the system can still perform in according with the requirements for the uptime.
And you would definitely want your entire BAS or DDC system tested successfully during the functional performance tests. I mean, it's a prerequisite that all the systems work completely before you do the IST test. And in fact, you need the DDC system in order to do integrated systems. So it's really going to be tested at that four level, don't you think, Alex?
Absolutely, absolutely. Because testing is not just turning on switches and sending on commands. You have to make sure that your sensors are calibrated. You have to make sure that everything is connected properly. So absolutely.
And then you made the important point about bench testing, because that's not common to most commissioning, but in data centers, with the amount of integration, the amount of assets available that have to be controlled, a lot of the control systems are completely tested on a bench even before all the equipment is installed, again, as a way to expediting success when you put it in the field.
Absolutely, and to address any issue that may arise during that test.
Yep.
Thank you so much, gentlemen. The next question is, I can actually see 2 questions on tags. So the first question is it a physical tag or is it simply a check mark on something like an equipment list? Can you please speak to the document? Sorry, it says, can you speak to the document control for tagging?
Yeah, you answered that really well when we did the run through the other day, Alex, about it being a physical tag as well as a virtual tag.
Absolutely. It is typically a physical tag. And the physical tag will be of a certain color. And so you can imagine where you have one tag coming after another, and every tag is like a gatekeeper, right? And the color of the tag will visually represent the state of equipment. So when you physically come to the piece of equipment, you see red color, what state that equipment is in, okay? Also, a lot of times you will have a QR code embedded into that tag. And so when you scan it, let's say with your mobile device, you can easily navigate to that asset on your in your mobile platform that you may be using. And also a lot of times those tags will have sign-offs, right, where multiple people, multiple stakeholders, it could be owner's team, it could be commissioning provider's team, and also a contractor that actually sign off on every asset. And again, that means the signing off on a tag means that you've just done 3 check marks, right? Your equipment gone through a certain phase of testing, your documentation related to that level of testing or inspection has been completed and available, and also people that will be operating the building are accepting that state of equipment.
And then, Alex, who's responsible for the criteria to achieve the tag? How has that worked out in a consensus?
So typically, a data center company, whether it's a co-locator or a hyperscale data center, will have a commissioning playbook. And a commissioning playbook will typically outline the entire commissioning process from owner project requirements to all the way to handover. And it will clearly identify the commissioning levels, including the responsibilities, who is responsible for what. And then it will identify those gates, what it takes to move from one tag to another, right? From one level to another. And so when they identify those, those gates, this is where they identify the tags, and they will also identify the colors of the tags specific to their requirements.
And then this works really well because you can correlate the color system onto spreadsheets and give people really insightful updates just through digital or paper reproduction.
Right. And also, it may or may not be, within, depending on the organization you're working on, but you can think of the color coding is also something related to safety, right?
Yeah.
Because the tag will tell you, the color of the tag will tell you, for example, whether that equipment is ready for, connection to permanent power, or whether it's already been connected to permanent power. So you can always tell, what state of equipment is at, by looking at the tag.
In fact, the red tag is a lockout tag, for example.
Absolutely.
Thank you so much, Liz. The next question is, all these levels of operational readiness for data center apply to most of the other type of buildings. What makes commissioning of centers different from all the other buildings?
That's a great question. We actually completely agree with this. The fact that those levels do apply to other types of buildings, especially to other type of mission critical buildings like labs, like airports, hospitals, right? There's really not a lot of difference there. However, there's still the difference come in where we're talking about reliability, where we're talking about the complexity, where we're talking about the types of systems, right? So that's where the differences are. And some, activities like, let's say, like buildings like airports. Yes, airports on day one has to be able to accept that plane that arrives at the gate, right? But you could always work, at night at the airport and collect maybe missing information or repair something. It is much more difficult to come back on day two within a data center and start finding missing information or start finding or addressing issues. Therefore, the level of testing, so I'm not talking about the levels of commissioning, but the levels, the rigor of testing, that's typically what's different, right? So that's, but again, can you apply operational ratings to other buildings types? Absolutely. Because remember when I said that operational readiness is a process, okay, which again can work for any critical facility, but it's also mindset. The mindset of engagement and handshakes at different levels between the quality and commissioning, right? So this is important at every building type.
There's a significant difference also in the stakeholders that get involved. In data center commissioning, we have to establish boundaries. For example, the building systems end at the IT rack typically. Or if you have co-location of power facilities, your SMR isn't going to be commissioned by the people or operated by the people who run and commission the data center. So you have to understand clearly where the boundaries are, but at the same time, you have to be able to communicate with the other side, because every aspect of the sequencing of the building systems plays into the ability to install things on the other side of the boundary on the rack. So server timing, installation of the racks, all of the items that go into the IT side, as well as how they're receiving power, whether it's a direct energy source or whether they're doing major transfer stations, but whatever they're doing, that's really a big difference that we see in data centers. So the communication, the stakeholders and the technology, like the water-cooled technology right now, to commission it, you have to have some interplay with the server side because that's what's immersed in the water, and they have to have a play on whether or not it's actually functioning correctly. So it's a different set of equipment than typical, different set of rules in terms of boundaries. And then, like you say, Alex, it's full stop. When the commissioning's done, the operators take over, and it needs to be right.
Absolutely, Jim. You're 100% correct. And again, the operational readiness process that helps data centers, get there, can be definitely applied to other critical facilities as well.
And should be. I mean, a lot of this is one of my interests here is because of the ACG building systems guideline, and data centers are, part of those building systems. So that's really cool.
Thank you so much. It's already 3, but we do have a lot of questions in here. So I would definitely suggest that Audience can take a note on the contact information that Alex and Jim have shared. If in case there's any question that you need addressed, that was something that was not covered here. With that, I would say thank you so much, speakers. Thank you for the informative session. We did see like insane amount of questions come in, so it's beautiful when we see such responses. Now to the audience, I would say if you are looking to sharpen your energy management skills in 2025, join us on March 20th for a 2-hour virtual training designed for energy managers and commissioning authorities covering essential techniques, real-world calculations, and strategies to cut cost and reduce energy waste. Visit energymgmt.org for more information. Again, thank you so much, everyone, for your time. Thank you, Jim, and thank you, Alex. Have a great day.
Thank you.
Thank you.
Bye.